Modern transformer networks rely on this concept called attention. And in attention, we are trying to model direct interactions between tokens. And in other words, we can say attention is a communication mechanism. That's why most of the modern large language models and vision language models use this transformer architecture. However, most existing analysis of how attention works depends on the idea of it is modeling direct interactions or static interactions. But the thing is that sometimes we want to understand how information propagates through the network. So a different perspective emerges when we examine the mathematical structure of attention, especially after this softmax function. So after applying the softmax, you can see the attention matrix becomes non-negative and each row sums to 1. This means it satisfies the property of a stochastic transition matrix, and this allowed it to be interpreted as a discrete-time Markov process. So under this view, tokens correspond to states and attention weights represent transition probabilities, and attention computation becomes a process of probability flow between tokens. So there might be multi-hop attention instances where information propagates through multiple states to this Markov chain. And the important shift is conceptual. Instead of asking which token attends to another directly, we analyze how attention evolves over multiple transitions. Standard attention visualization corresponds to a single transition step. But if one token attends to a second token and the second token attends to a third token, then we can say information indirectly flows from the first to the third. Single step analysis fails to capture this idea. This leads to the idea of multi-bounce attention, where attention propagation is iteratively computed using this equation. And this is the power method to reach steady state. And each iteration models another stage of information flow through the token graph. And if you are familiar with Markov chains, you may know that once this process, this update happens again and again and again, after some time the system becomes stable, and we call that a steady state. And repeated transitions reinforce semantically related regions while noisy connections gradually disappear. Tokens belonging to similar concepts form stable regions known as metastable states. And that is the idea. And if you are familiar with PageRank of Google, then this idea is very much similar to it, and we call this token rank.